Can you guys hear me?
Yes, sir.
Okay. All right. So yesterday we spoke about the architecture of the Ascent processor. Yeah, this is the spoke about the Da Vinci architecture. Is there any question on that? Any question on that? All right, so we've learned that these processes are also called accelerators. It's just computing power that will empower the AI ecosystem. So today we're going to move forward with the software architecture of Ascent. All right. So remember when we say in order for us to deal with the four elements of AI, the data, the algorithm, the scenario, and the computing power. So they all work together for us to create what we call an AI model or an AI tool. And we've gone through this course, and you've seen that we spoke about different parts of this, okay, which will play a role in creating our AI tools. So in terms of AI applications or framework, we spoke about MindSpo, right? MindSpo, TensorFlow, PyTorch. So all these, okay. So now today we're going to talk about the CAN AI heterogeneous computing architecture. So this CAN is basically, this architecture is actually giving us access to the application side. So basically CAN will stand for, this is the compute architecture of neural network. Okay, so when we talk about CAN, we're talking about a compute architecture for neural network. So basically this is just a deep learning computing framework, right? It's a framework that was developed by Huawei, which will also support all the Ascent processors. So remember, this is a framework. So this is a framework that was created by Huawei. So CAN will stand for Compute Architecture for Neural Network. So basically, this is just a framework that was developed by Huawei. It supports Ascent AI processors. So we will have the Ascent 310, which help us in inference, and the 910, which help us in training. So this framework will support this. Okay. So basically, this CAN will just serve as a software foundation for us to create all our AI models. Okay, so it works like MindSpo, TensorFlow, but this time now we have the computing power as well, not just the algorithm part. Okay, so this will help us to really have a high performance in terms of training our model and in model inference. Okay, so now the way it works in terms of its architecture. So we have an Ascent computing language, okay, which come with different APIs. We have an Ascent computing service layer, which will have different neural network libraries and We have an ascent computing compilation layer. We have an ascent computing execution layer. And then we have an ascent computing base layer. Okay. So these libraries, for example, that we're going to have here, will be libraries that are going to help us. For example, when we're building all the neural networks in terms of convolutional networks, the activation functions, and the reason why this is called heterogeneous computing architecture is because it can also support execution of the code across multiple devices. Okay, so that's how it's going to work. So we're going to have, for example, as part of ascent computing language, so we have the TB API. TB just stands for Tensor Boost Engine. So these are modules that can help us in terms of compiling and optimizing the AI operators. In this case, and when we're dealing with languages, and then we have the Ascent computing libraries. Okay, so we have Ascent computing libraries. So basically, this is also kind of an interface between the hardware and the AI framework itself. We also have the Ascent Tensor compiler. So this is just to deal with compiling all the tensors operations. Okay, so the whole purpose of having this CAN architecture is just to help all the developers to basically use this framework in order for us to really work together from the algorithm to the computing power, and just to get kind of an acceleration of how we're building this model. So it's gonna basically kind of bridge the gap between AI models and hardware instructions. So we basically working with that. All right. So now, in terms of the applications, as we've mentioned, so we dealing with all the frameworks such as MindSpo. It works like MindSpo. So in terms of we will have inference applications, and we will have also training applications. Okay, like you have what we call Mind Studio. So the Mind Studio IDE. So can anybody tell us what is the meaning of IDE? What is the meaning of IDE when we talk about IDE in programming?
Isn't it where you actually write your code? Could be your Visual Studio or Microsoft.
Yes.
I forgot.
No, it's not. Yes, your yes, but what is the meaning of IDE? You are right by saying that when you write code.
An integrated development environment.
Perfect. So now you have Mind Studio. Mind Studio is just an IDE, which is incorporated into your all this architecture of CAN, right? So that is going to be the IDE that you're going to use. So this is really specialized for building, training, and deploying AI models. Okay, the advantage with that is that it's basically it helps you build these models on the Ascent AI processors, such as the Ascent 310 and the 910. So how do you access those processors? Through MindSpo and through CAN. Remember that, right? So basically, this Mind Studio IDE can work together with the CAN architecture or MindSpo that will give you access to all the AI processors as you're building your model. So it's not going to be very easy compared to if you say you want to build a model and then you want to use maybe VS Code. So whatever extension you're going to put on your VS Code IDE is not going to be as better as using Mind Studio connected with MindSpo or CAN framework, which will help you access all these processes. Okay, so those are the advantages, because it helps you even in terms of model deployment, because Mind Studio supports training and any operation such as optimizing all your models using MindSpo and even TensorFlow as well. So that's one of the advantages of using Mind Studio. All right. So now we have this in this architecture. As we said, we're gonna have our Ascent application. We're gonna have our Ascent computing language. Okay, and then we're going to have the Ascent computing service layer. All right. So basically, the Ascent computing language, or Ascent CL, right? So this is another framework for I mean, it's a programming framework for Ascent computing. So it will basically shield the differences between underlying processors and provide the tensor boost operator. Okay, so basically this ACL will basically be kind of think of it as a programming interface, right? It's just a programming interface which will actually where you will directly interfere with your processors. Okay, so the Ascent computing language is just a programming interface, which is obviously developed by Huawei because it's part of the CAN computing architecture. So, so basically, this is just an interface that will help you interfere directly with your processors. Okay, so it's going to give you access to things like managing your memory, managing how the data are being moved, you know, and then which hardware is using those data and all those things. Okay, so so basically the ACL will directly interact with the AI processors. Okay, so when you have, for example, on NVIDIA GPUs, something that is close, something that works like the ACL is called the CUDA. It's called CUDA, C-U-D-A. So CUDA works as well like the ACL, the Ascent computing language. So remember, just to summarize that, so this is the ACL is just the interface, a programming interface that will help you interact with your AI processes. So what can this ACL do? So basically, it's gonna help you with initializing your Ascent devices. So everything that has to do with managing how the data are being used, managing how the resources are being allocated. So you basically have the ACL that will deal with that. So it's going to initialize the Ascent devices. It's going to allocate all the memory and on any device that is using that, right? So it's basically execute if in case you're dealing with it in inference. So it's basically going to execute all the operation during inference. Okay, so as we said here, it works with these other operators that are part also of the architecture. Okay, and then the third one will be the Ascent computing service layer. All right, so what is the computing service layer? So basically, this is another component, right? It is another component of this architecture, right? So basically, the way it acts, the way the computing layer would act, is that it's going to create kind of a bridge between all AI application and the hardware as well. Okay. It also helps with managing how all the computing tasks are being scheduled. Okay, so this is also another component of this AI chip architecture, or the ASCENT architecture. So it's going to help you in terms of managing the memory, remember yesterday we spoke about the AI core, so basically the computing service layer is going to help to manage the memory, the AI core, the buffers, and all those things. So it's basically will kind of provide the support in terms of loading the models or running the models. Okay. So that's what it's going to do. So basically, when you look at it in terms of where it fits in the whole ecosystem. So once we have the application that we're using, for example, here we're using Mind Studio as the IDE, which we can use on different applications such as MindSpore or TensorFlow. Now we have the ASCENT computing language here, which give us the interface, right? It gives us the interface. It gives us access to different libraries, right? So it's basically as a face for the developer to actually manage how they're going to allocate the resources and how they're going to deal with the AI processes. And then you have now the computing service layer, which is now going to deal with scheduling all the tasks, managing the memory. Okay, so that's how it's going to work. Okay, all right. Okay. So basically, if we have to have an architecture without the computing service layer. So if we don't have a computing service layer, so what will happen is that as developers, you will have to manually manage your hardware resources, memories, and all those things. Because remember now, as you training a model or using a model, you need to allocate the hardware resources, which resource it's going to take. If you only have access to a certain amount of space, for example, which hardware is going to use what amount of your bandwidth? Okay, so developers will have to manually set that if we don't have the computing service layer. But if you have a computing service layer, this is going to manage it for you. Okay, so that's how that works. Okay. Okay. Now we have the ASCENT computing compilation layer, right? So basically, the compilation layer will just use the how can I say it? You remember when we spoke about the intermediate representation, the IR, when we were creating TensorFlow, when we were talking about building models with TensorFlow, not TensorFlow, with MindSpore, we mentioned a part called the IR. Okay, so in terms of compiling, if we want to compile all the graphs with the IR, so this is the part of this architecture that is dealing with that, the ASCENT computing compilation layer. So now this part of the architecture is going to deal with the operation when it comes to dealing with graphs, for example. Okay, so and then we have the next one will be the ascent computing execution layer. Okay, so the execution layer will be will help us with executing the whole model and all the operation in a model. So we have to include certain modules such as all the libraries that you're going to have. We have not just the libraries, we have all your DVPP, your pre-processing operations, and all the operations that are happening there built on the computing execution layer. And then we have the ascent computing based layer. Okay, and then we have the compute resources. We have the computing resources. Okay, so these are some of the layers that we have. So now when we think of the computing execution layer, for example, so this is basically these components on the Ascent AI software stack, right? Remember, all these components are part of the CAN, right? They all play different roles. So, so when we have operation running of certain AI operation, right? Remember, these operations are happening and they are using the hardware as well. So when these operations are being executed, the component that is managing that, the component that is responsible for the execution and the running of AI operation is the Ascent Computing Execution Layer. Okay, so this, remember now, the type of instructions that are going to be executed if we're dealing with, if the AI is doing some matrix calculations as part of the Da Vinci architecture, the part that is going to be directly used is the cube units, as we spoke about it yesterday. So this is how all these components are working. So let's say, for example, you're running an object detection model. So if you want to run that model to detect certain object, so you load that model, or maybe you create the model using Mind Studio, right? And then the task scheduled, right? Every task that is happening with the model will be scheduled by the computing service layer. And then now, has you the where is it? So we're gonna have the computing service layer that is going to do what? To schedule the tasks. So this is the task that need to happen at this time. The first task that needs to happen will be maybe a certain network from this, and then, you know, the allocating, managing the task. So that will be done by the computing service layer. And then after that, let's say, because it was an object detection, remember the type of neural network we're going to use? We're going to use a CNN. A CNN. And remember, in the CNN, we have operation that need to happen with the convolutional layer, for example, where we have all those calculations that we spoke about last time, which are matrix calculations. So those calculations, those operations, in terms of how those calculations are going to happen and the activation function, those will be passed by the computing execution layer. That's what the computing execution layer will do. Okay, so the execution layer is the one that will deal even with all the operation happening in the AI core itself. Okay, so that's how this this operation can actually be done. Okay. Okay, so this is just a neural network software flow of the Ascent AI processes. So we have our apps that we've made. These can be during inference as well. So the flow is that we're going to have, if we have third-party frameworks such as maybe we have TensorFlow or PyTorch, right? So, and then we have the CAN ecosystem here. So the whole CAN, we can actually introduce whatever operation is happening from a different framework. We can actually integrate it into this CAN. So we have the this flow, the Ascent processor this will be kind of a bridge between the deep learning framework and the Ascent processor. So the CAN will deal with both algorithm part and computing power. All right, depending on what task we are actually trying to do. Okay, so after the Ascent, after the Ascent processors, we're going to look now at the Huawei Atlas computing platform. Okay, so is there anyone who has heard about the Huawei Atlas before? Anyone? Has anyone heard about the Huawei Atlas? Okay, so when we spoke about the Ascent processors, so the Ascent processors are those chips. We spoke about it. Those are part of the computing power. So we have the 310, the 910, and we've learned about different frameworks such as the CAN, which is the framework where you can actually put together the MindSpore or MindStudio and the AI processors. So now we have the Huawei Atlas AI computing platform. So this now this now is not just a solution for the software part or for the algorithm part, but this is a solution for algorithm and for hardware. So this platform actually works as a solution for algorithm and for the software, right? So it will support developing your AI and deploying them, not just in the development when you create your AI. No, in terms of developing your AI, your model, you can use the Atlas platform. In case of you want to deploy, you can use the Atlas platform. Okay, so this Atlas platform is built on numbers of AI processors, like a series of AI processors. So this is just going to provide us with something very powerful in terms of being able to build AI models, train them. Okay, even if the models have to be deployed on the cloud, we can still use the Atlas platform. Okay, so which type of AI processors does the Atlas use? The Atlas will use the SN310. So we have the SN310 for inference and the 910 for training. Okay, so this will be the in terms of the processors that are going to be used by the Atlas. Okay, so now we're looking at the whole Atlas ecosystem here. So we have many industries where this can actually help us. Okay, because this is a full, a complete package for us to build AI tools, because we have access to CAN, where we can build that and create a bridge between the software and the hardware. We have access to all this. For example, you have the Model Zoo, which is a library for different models that are pre-built. You have Mind Studio, which is an IDE that you can use. So no need for you to download another IDE to start creating your model. You already have this. So in terms of framework, you have MindSpore, you have other third-party frameworks such as TensorFlow, PyTorch. So you have access to all this. Okay, so which industry? We can really build models for the energy industry, finance, the public sector, transportation, telecom, manufacturing, you know. So basically the Ascent full stack AI software and hardware platform is such an intelligent world. So we basically have everything that we need to create the AI tools. So we have all these frameworks that work together. And now when we want to now connect it and create the models, we need the computing power. In terms of the computing power, we look at all the Atlas hardware, all the hardware supported by Atlas. You have, for example, an Atlas 200, which is just an AI accelerator, which will work for edge devices. You know, you have your routers and all those things. And then you have maybe the Atlas 300, if I'm not mistaken. That's one work for data center. So in different scenario, you have the right computing power to use. For example, if you're training your model, the model is so big and you need advanced, you need to look for something like the Atlas 800. But we're going to talk about all those. But what we can say here is that with the Atlas hardwares, you have access to hardware for inference, for and for training. So basically, you have on all scenarios, whether you want it for the device or for the edge, for the cloud. So you can get it. Okay, so those are certain packages that you get. So this is, for example, the Atlas 200. Okay, so the Atlas 200, so this is how it looks like. So if you get, for example, the Atlas 200, so you need to understand this accelerator. So this computing power or this device is for, it's considered to be an edge device. All right. So the Atlas 200 accelerator, this is used for in device side, okay, such as in smart cameras, in robots, the drones. So those small drones that you have that are dealing with object recognition or image classification, they are actually using an Atlas 200. I think last week I have a friend of mine who came to me with a very small drone that you basically don't need to actually control it through the phone or a tablet or anything or any device. So all you need to do is just turn on the drone, and then you press a button, and then you scan your face. So after you scan your face, now the drone knows how your face look like, so it identifies you, and then it can go up. So as you move, the drone is following you. So that can be used. Let's say, for example, you always run in the morning or evening, whatever, but you want the drone to start following everything that you are doing as you're running or moving up and down. So as you're running, the drone is following you because you've already scanned your face. So that drone that you see there, for the model to be smart now, because remember the data that when you press, it's connected maybe to your phone, to an application where all the data of your face was sent. So it needs to work in real time. And for it to work, that when we have this chip, you have the Atlas 200, AI accelerator. So this will accelerate all the operation happening there. So this works in cameras, robots, in drone, industrial computers, video analysis, So this work when you're dealing with image segmentation, object recognition on these devices here. Okay, so this is the Atlas 200. Okay, so as you can see, this is the Atlas 300. So the Atlas 300 is also an accelerator card, which will be integrated for general purpose processor. So this is used mostly in kind of data center. Okay, when we're dealing with so many data there. So like let's say for example you create all the robots on the road are sending information to a certain data center, and the information are being, for example, we monitoring the traffic and see, okay, this is what's happening in certain time, if the traffic is good or the traffic is bad, and then we monitor all those moves there, and then from there we can be able to say, from this time to this time, all the roads, maybe the robots in certain roads needs to be open, need to be green for a longer time. So when we look at all those information there, so now we need an AI accelerator card that will make the whole process happen really in a short time. So that's when we can use something like the Atlas 300 when we're dealing with scenarios where we're dealing with like smart transportation, smart cities, So in those type of scenarios, they smart finance, smart campus. So basically, when you have those data centers where you have so many data coming in a short time and things like that. So those are that is an example of how we use the Atlas 300. Okay, so because why we use that? Because Atlas 300 will help us in terms of analyzing so many data at the same time, like you're dealing with videos, images, so you have so many things at the same time. In real time, it's actually a real-time analysis, so that's how the Atlas 300 will work. Okay, so that is the 300 V Pro video card will work in that case. And then we have the 300 Pro inference card. This will work as well in certain scenarios where we're still dealing with high amount of data. But this one is basically specialized in terms of speech analysis, such scenarios, not really in terms of images, but it's more like in terms of speech scenarios, in terms of analyzing some text from different documents, things like that. Let's say, for example, you have a service such as the Department of Home, for example. Every day they're dealing with documents, someone can come do certain applications, they submit certain documents. So when we have an AI tool that is looking at maybe some document and extract text, send the data to a certain data center that's deal with that. So the best computing power that you're going to need in those type of scenario will be the Atlas 300L Pro Inference. Okay. Okay, and then you have the 300 Duo Inference. So this one is also integrated on different servers that also work with, at the same time, with speech analysis and video analysis. So this one combine the 300 inference, Pro Inference, and the 300 Pro Video Analysis. So instead of purchasing two of this, you can just have one, which have both options. We can deal with video analysis and speech analysis. So basically, it does all the contents analysis, the videos, speech, So it can be used in smart transportation, smart cities. Okay, so this is the Atlas 300 Duo inference card. Okay, and then you had the 300 training card. So this one will be used mostly when we now dealing with training. All right, so this is not really for inference, this is for training. So now when you're training these models to perform this operation, you're teaching the model to understand how to actually analyze data. For example, if you use it in smart transportation, how do you get to a point where your data now, your model understand how to look at different traffic and analyze those data. So when you're still training the model, during model training, you can use this chip, which is the Atlas 300 Pro training card. Okay, can also be used in smart finance, smart manufacturing, so in different companies, seeing how you can do that. Okay, so it's the chip. This chip is built on the Da Vinci architecture as well. And then these are some of the specifications. Okay, so remember, guys, all these computing power will depend on what's your scenario and what you're trying to do. And if you are looking for an accelerator for inference or for training, that is very, very important. Okay, and then we have the 500 AI. So this one is basically an edge station with integrated AI capabilities. So how do you use this? So basically, if you need to analyze data from a robot, for example. So let's say there's cameras at the robot. So those information need to be real time. Those information needs to really be sent at the right time. If you're dealing with the activity in the shopping mall, everything needs to be in real time. You're dealing with activity in the supermarket and everything. So if there is certain AI operation that are happening, so you can't just get images from the camera, use normal internet to send it somewhere, and then you analyze it. By the time the data are analyzed properly and send the feedback, maybe it was used for security. It's too late. The suspect of a certain crime is gone already. So that's why, in terms of age, so to try and accelerate how data are being transferred, we can use the Atlas 500 edge station. So this server here is equipped with AI capabilities. So it can be used in smart transportation, smart communities, where you actually trying to monitor the whole community and analyze different data, smart building, and different other scenarios. All right, guys. And then we have the Pro Edge server, which also work as the previous one, but this one is more advanced, has more capabilities, and it's used in bigger scenario as well. It's also used in transportation, in community, security, shopping malls, supermarkets, right? So as you can see that. All right, so now we have the 800. The 800, you need to know this 800 is at the same time very good in inference and as well in training. But in terms of inference, so you have, for example, the model 3000. The model 3000 is specialized for inference. So this model 3000, so on this model 3000, inside you have the Atlas 300 Pro card, which is incorporated in there, which will deal with video analysis. Remember, we spoke about the Pro card, which deal with video analysis. So now, when we're using the Atlas 800, it helps us with real-time inference, because inside it we have the 300. We have the 300 cards inside it. So this is mostly used when they're dealing with scenarios such as analyzing videos, for example, in hospitals. They can analyze medical images, smart finance, smart cities, smart healthcare, where the whole healthcare ecosystem is being controlled by AI. So we have this Atlas 800 that can be used for inference in that area. Okay. And then the 800 for training, which is the model 9000. The 3000 is for inference, and then the training, you have the model 900, which we use to train in the same areas where the one for inference is being used. All right. And then the last one will be the 900. So the 900, you must remember, this is a large-scale AI training cluster, which is designed for high-performance AI workload. I'm not too sure how much it is, but it's expensive, this one. Okay, so this one is for AI cluster, for AI training. So it's used to train all these models that will be used in smart healthcare, in smart cities, and different areas as well. All right, guys, I think that will be all for today. Is there any question? Is there any question before we can call it a day or call it a week?
So,
Yes.
a bit unrelated, ne? I was trying to download the slides, ne? And then I realized there's two versions of AI. There's a 3.5 and a version 4. Which one are we writing based on?
Where were you trying to download it?
On the Huawei platform. Because even if you try to go to my classes, it redirects you to a version 4.
Okay, no, it's the 3.5. There's not much difference. 3.5 and 4, there's not much difference. There's just a few things, such as few images that they have there. Yeah.
Okay, no, that's understandable, so thank you.
All right. Okay, guys, please, because from next week, depending on how far we move next week, but in the next 2 weeks, we should be done with AI, and then you will have to write your mock exam. And if you pass the mock exam, then you have a voucher for the main exam. So I would suggest that you take some time to go through the material, go through the videos, because for AI, we have all the videos from the first class, so that you can ask questions and make it better this time. All right, guys. I will see you on Tuesday.